All right, so we're looking for an absolute minimum, but we're not in a closed interval. So that means we're not testing the endpoints. But we do need to know if this graph is going up on both. We need to know the end behavior of it. Now I know that I know what an x looks like. That graph goes like this. I know what an e to the x looks like. That graph goes like this. So it looks like if we were to multiply these y values together, let's see, all of these would be positive. And if I put a 3 right here, it's not really going to change anything. But we have the negative x values will give you a negative y value. And if I multiply a positive by a negative, that means, yeah. So, but I'm assuming there might be something happening right around here when x values become fractions. So I'm going to see if there's a critical value there to see if we have absolute minimum. Oh man, let's think about that for a second. I want to plug in like a really negative number. Let's plug in negative 10 to this really quick. That one's really negative. If I plug in negative 10 into this, what are we going to get? E to the 3 times negative 10. Let's see, that would be negative 10. And so we have e to the negative 30. Oh shoot! Well, let's pretend this is e to the negative 30. So that's a positive number, right? Yeah. So if that's a positive number, then I could just say this is a positive number. Whoops. It's a positive number times a negative 10. That would be a negative number. And I think what that helps me see is that the farther negative I get, the bigger the negative number will be. And so if I'm going to the left side of my graph towards negative infinity, the graph looks like it's going down.
Well, isn't also
right?
e to the negative 30 super small?
E to the negative 30
So
is
like
super
big
small.
Number,
Yeah, because you're right. Because then that would be negative 10 raised to the 1 over e to the 30. So, oh, I see. This is like the same scenario that we had last time, huh, Alex? Okay, so this number is trending towards 0, which means this is actually not going to be going down like that. It's going to come back up, and it's going to get really close to the 0.
Wait,
so it would have a minimum
I'm
value.
confused on by that number. Wouldn't that make it slightly larger?
Well, here's the thing. So technically, if we go to negative infinity,
Oh, it's negative, okay.
yeah, if we go towards negative infinity, the number on the bottom of this fraction is going to get really, really big, right? And so,
I was thinking, okay, I understand how I was thinking about it.
yeah, so that if you think about limits,
No, I get how it's getting bigger.
oh, you remember it?
I get how, like,
It's
my
going back
problem
to
was,
0?
Like, my problem, what I misunderstood was when you multiply the 10 to,
Yeah.
like, it was like, doesn't that technically make it bigger? But no, it's negative 10, so I'm thinking about it the opposite way.
Oh, yeah. Okay, so let's find g prime to find our critical value. Where does this function stop going down and start going up? So we have the derivative of x, which is 1. Then we multiply it times e to the 3x plus. Then we have x times the derivative of e to the 3x. And so we have e to the 3x times the derivative of 3x because of the chain rule. And so we have, I'm going to factor out an e to the 3x. And I have 1 plus 3x. So I took this guy and this guy out. And so I'm left with that. And I'm going to set that equal to 0. So using the zero product property, I'm going to set each of those equal to 0 and solve. So e to the 3x equals 0. And then 1 minus 3x equals 0. Okay, so can e to the x equal 0? And the answer is no. We cannot plug any x in to make it equal to 0. And if you guys know what e to the x looks like, you can see, look, it'll never the line will never have a y that equals 0. So this one is no solution for this one. But this one over here, we have negative 3x equals negative 1. And if I solve that, I get 1 over 3. So it says...
How is it negative 3?
Negatives cancel.
But how's it negative 3?
Plus
That's
3x.
plus
You turn
3.
into 1 minus 3x. Still
Yeah,
the
it
same
just magically becomes minus. Sorry.
No, it's not.
So this is a negative, right?
Yeah.
Okay, so that's where the absolute minimum is, but that is not the absolute minimum value. Remember, absolute minimum value is a y value, so we must find the y value now. So we got to plug that back into the g. I plug it back into the g, what do we get? let's see, negative 1/3 times e to the 3 times negative 1/3. That would be
That's why.
negative 1/3 e to the
Negative
No
1.
way.
negative 1. So then it would be negative 1 over 3e.
Yeah.
It's always negative.
All right.
It's not that